Here we're looking at sodium chloride. Sodium has a +1 charge. Chloride has a -1 charge. So +1 -1 adds up to 0. So they balance. In some cases, the charges will not be the same. You could have a +2 and a -1. In that case, what would happen, I don't know what that is. I'm going to just close it. If that happens, then you need more of the one with the lower charge. And the way the math works out here, the charge of one often will determine the subscript of the other. So if you have a +2 charge and a -1 charge, you need 2 -1s to balance the +2, and 1 +2 to balance the 2 -1s. Okay, so we'll see some examples of doing that. Okay, so these are ionic compounds. A lot of what we'll be looking at will be ionic compounds today, and in lab we'll talk a little bit more about molecular compounds. Okay, we looked at this last time. I want to talk about it a little bit more today because now we're going to be using this as we look at ionic compounds. If we look at the periodic table, we can get a sense for what kind of a charge things will have based on where they are on the periodic table. So again, things in group 1 will tend to have a +1 charge. Things in group 2 will tend to have a +2 charge. Things in group 3 will tend to have a +3 charge. So you're basically going across the periodic table +1, +2, +3. We skip over the transition metals for that. We'll actually talk about a little bit later, maybe today, maybe not until lab next week, but we'll talk about what do those do, and it turns out they're not as predictable. But we'll figure out what to do with that. And then going to the other side, the noble gases, so group 8 does not have a charge because it doesn't usually form compounds. So the last group you leave off, that doesn't do anything. And then you go to the halogens. Halogens are -1, and then you go over one more -2, and then over one more -3. You'll notice there's one group kind of in the middle there that's sort of left out. It usually doesn't form a charge. So it has to do something else to form compounds. So we're looking here at how ionic compounds form. So +1, positive charges for the metals, negative charges for the non-metals. Okay, so let's look at some examples of some ionic compounds. Okay, let's talk about some examples. Does somebody want to give me? Somebody pick a metal from one of those regions we talked about. So pick from the metals that are showing up on this periodic table. Okay, so here gallium Ga +3. So if you look at aluminum and you go down, you have Ga with a +3 charge. And then somebody pick a non-metal. Oxygen. So oxygen has a -2 charge. Okay, so how this is going to work, if you have gallium oxide, if you have that compound, how that needs to work is you have to have the charges add up to 0. So you have a +3 charge for the gallium, and you have a -2 charge for the oxygen. And somehow those have to balance out. This is probably actually the hardest one you could have picked. So it's a good thing we're going through it now, right? So you don't know how to do all the others. The easiest way to do this is the charge of one is a subscript on the other. So when we look at this, we'll say Ga. What I'm going to do, I'm going to go ahead and put this on the PowerPoint so we can look at it as we go. Okay, so we have Ga with a +3 charge, and we have oxygen with a -2 charge. So how we make this work, the charge of one is a subscript of the other, So we have Ga2O3. And I'm going to go ahead and make these some subscripts. I should make superscripts for the charges. I'm not going to take the time to do that right now, though. Okay, so that's how we would do that. That's how we would figure out the charge, or the formula for that ionic compound. We look at what is the charge of the metal, what is the charge of the non-metal. They have to add up to 0. So we have plus 3. We have that twice, so plus 3 is plus 6. And we have minus 2. We have that 3 times. Minus 2 minus 2 minus 2 is minus 6. So plus 6 minus 6 add up to 0. And that works because the charge of one is the subscript of the other. Does that make sense?